Hello. Today we're going to talk about Topic 1, Section 7 of Cognity. We're going to also talk about 10.2 of the textbook. Okay, that's the compound interest. I figured we'd go back and review a couple of these problems first. So, Carolyn is starting a new job. She earns $48,000 in her first year and increases 5% each year. Okay, just a flat 5% every year. So it follows a geometric series. What we do is the first year is 48,000. That's in the first year. In her second year, she's going to make 5% more of that. Well, think about it. She wants 100% of that. And she wants to increase it by 5%, so she wants 105% of 48,000. 1.05. That's how we write 105%. All right, to get year 3, we multiply 5% times that. 48,000 times 1.05 times another 1.05 because we want 105% of the year before. Okay, and then you can keep going. All right, so we want to know what she makes in her fifth year. So we follow our geometric formula, right? So her fifth year is equal to her first year, which is 48,000, times her rate, and then n minus 1. 5 years, so 5 minus 1, 4. Okay, so then we just plug that into our calculator. All right, so our calculator gets, use my pen. So in the fifth year, it is $58,344.30. Okay, that's how much she will earn in her fifth year. Yeah, that would be nice. Anyway, next problem. All right, Mr. Farmer buys machinery for $25,000. It depreciates at a rate of 8% per annum. All right, so annually, 8%. So we're going to find the value after 5 years. All right, don't be fooled here. The first term is not just 25,000 because in the first year, all right, it actually depreciates by 8%. So the first one is actually 25,000 times that decrease. Now think about it. We're not taking 100% of what we had. We're taking 8% less. Depreciate means less, so subtract. So 100% minus 8% is 92%. So I'm going to write that out. 100% minus 8%, again we're doing that because it depreciates, is 92%. So our rate is 0.92. Okay, we want to find the value after 5 years, so we use our geometric formula to find the nth term. So in the fifth year, we're going to take 25,000 times 0.92, that was our first term, times our rate, 0.92, and it's the fifth year, so 5 minus 1, or 4. And again, this is the same thought process of going, okay, I need to go 5 years. Every year, we do 8% decrease, so 25,000 times 0.92 to the fifth. Okay, 2 ways to get to the same idea. Okay, both answers are right. You plug it into your calculator, you get this as your answer. Okay, so after 5 years, it's only worth 16,000. Pretty unfortunate, because I'm sure he probably owes more than that on it. Anyway, so next one. Find how many years it is before Mr. Farmer's machinery is worth half its original value. Okay, so we need it to equal half of its value. Let me change my color. So we want it to equal 12,500. So we know the nth term must equal that. Well, the first term is this. So we can use our solver to get this. Okay, in the next lesson I'll show you how to do it with logs, but let me show you with the calculator. Okay, so let me show you where the equation solver is. Go to Math, and I'm going to go down or up and go to the solver. Some of the older ones say like numeric solver or equation solver or something like that. So I put in the left side. So, whoa, my number's way too big. That should have been 12,500. Looks like I just really wanted those zeros there. Okay. So then we enter the right side of the equation. And we have 25,000 times 0.92 to the x. That's our variable. I hit OK. Alright, here we put a best guess. Takes, what, 10 years? I don't know. I'm putting a guess. I can put a bound here. This is pretty much a long ways to the left and a long ways to the right. Okay? Times 10 to the 99, so a whole bunch of zeros. We could narrow this down because we do know that it's 0 to a positive number, but we didn't have to do that. We could have left it alone. Alright, so then we hit solve. Okay, maybe I need to actually hold on. This is different than my calculator. Okay, sorry. Technical difficulty. So here you have it in your equation. You hit OK. And then here it probably doesn't say the same thing you have. We're going to hit alpha enter, and that's going to solve for x. And that's when 8.31 should show up on your calculator. So that's an equation solver on your calculator. Okay? So this answer is 8.31 years. Okay? Alright. Rafael invests in Brazilian real, 5,000 Brazilian real in a bank offering 2.5% interest compounded annually. Okay, so that's the key word here, is compounded. That's when we use our formula. Okay, that's when we use future value equals present value. Was it 1 plus r over 100k to the kn? Okay, so calculate the amount of money he has after 5 years. So we plug it into our formula. 5,000, 1 plus 2.5 interest, 1 times 100 to the 5th. We work that out. Okay, we can also use our calculator app. Okay, we did that last go round, but here, let me show you. Where's my calculator? Alright, so you want to exit out of this, so quit. We're going to go to apps, finance, the solver, and here we have this happening a total of 5 times, once a year for 5 years, so that's going to be 5. Our interest was 2.5. Alright, our current value is 5,000, that's what we put in, so we're going to make it negative. We're not talking about payments, and we just want to know what the future value is. That's what we want to solve for. So here I'm going to hit alpha solve. Okay, and notice I get 5657, and notice what the answer was algebraically, 5657. All right, let's do it again. What about after 5 years, he withdraws all of it and puts it in another bank, 2.5% interest, compounded monthly. So obviously we got to do something different. So we plug that into our formula. Notice the K is now 12 because it happened 12 times a year. So K is how many times a year, N is the number of years. So we solve that algebraically. And by say that, I mean put it in your calculator, because that's definitely what I would do. So this is the answer here. So to put it in our calculator, we should do the following. Okay, notice what we changed, what we put in. 2.5 interest. All right, it happened 3 years. And then we changed CPY. Okay, so how many compounds per year? CPY changed to 12. Okay, so that's how we put that one in our calculator. All right, let's keep going. All right, pause this, try it, give it a whirl. So the first one, we want to calculate how much she has in the bank after 6 years. So algebraically, plugging into your formula is this. So you should get this many Russian rubles. When you plug it into your calculator, you should use these commands. Okay, and you're solving for the future value. Notice the compounds per year changed to 4. Okay, that's how I would do this. Okay, next one over here, we would we want the original amount to double, so it's going to equal 160,000. So you can use the numeric solver. I can show you how to do this with logs in the next lesson, or use the finance app. Okay, that's probably what I would use, honestly. Okay, but then I would put the cursor over N and solve for N. Okay, so hopefully me talking about what goes here makes a little bit more sense here. So N is the number of years, compounds per year is down here. Okay, that's interest. So let's talk about our inflation rate. Okay, so we want to work out the percentage increase. Well, first let's think about the inflation rate. We want to know what happens to the dollar. Okay, we always break it down to that single unit. So that's going to have an effect just like interest would, right? That inflation rate, that interest is very similar. So we're going to treat it the same and use the dollar amount. So here, over 5 years, the US dollar will become this formula. Okay, notice we did 1 plus the interest over 100 to the 5th power because it was over 5 years. Okay, which is a 24.5% increase. Okay, you're probably thinking, well, okay, but that's not what that says. All right, you're right. That says it's 124.5%. Okay, but there's no way I'm going to increase an additional 100% over my original. Remember, 100% comes from your original amount. So here, we're going to increase by 24.5%. Okay, so that's where they're getting this number from. All right, so now a computer game is going to cost $35 today. So what would you expect it to cost the next year due to the inflation adjustment? Okay, did you get an idea? All right, that's it. It's just that simple. We do 35 times 1.0448. Why 1.0448? Because that's the inflation rate. That happens for every dollar. So we have $35, so we need to increase them by that much percentage. So 100% plus 4.48%, being silly, is 104.48%, which is that number as a decimal. Okay? So that's going to be the increase of our gain. So really, not that much. Okay? 1 year really doesn't make that difference, but probably over 10 years. Okay? But then again, it's a computer game, so it's going to decrease in value. All right. Next one. So what if we want to make payments at regular intervals? Okay? An annuity is a fixed sum payable at specific intervals. All right, usually annually and over a period, such as the recipient's life, in return for a premium paid. So we're talking retirement, things like that. You're getting paid back for what you put into it. Okay, so I would use your calculator, use your calculator, use your calculator. You need this finance app. All right, Google how to get the finance app on your calculator. You got to get a wire, hook it up to your computer, transfer it over. Okay, so let's see. We have, all right, Anmol would like to have 1,000,000 Turkish lira at the end of 10 years. Well, wouldn't we all? He saves every year in an annuity that pays 4% interest. So they're paying him to hold on to his money. Okay, that's a thing that happens. So we are going to do this over 10 years. We have a 4% interest. Okay, doing good so far. We are going to, let's see, this every year that pays 4% interest. Okay, so our PV is 0, right? We're not putting anything in. Our future value is 1,000,000 because that's what we want to have at the end. All right. PPY, we'll get to that. And then CPY, compound per year. Okay, so again, let me rephrase that. He's going to put money into an account every month, and it's going to have a 4% interest rate. Okay, how much does he have to put in every month? So at the end of the 10 years, he gets 1,000,000 Turkish lira. All right, that's what we're trying to find. So we put that into our calculator, and we solve for the PMT, the payment. Okay, when we do that, we should get 83,290.94 Turkish lira. Okay, so he's got to try and save that every year for the next 10 years. Why did I say month? He saves every year. It said it right there. Where did I even get month? Apologies. Nowhere did they say month. I don't know why I said that. He saves every year. So he needs to put this much in every year for 10 years at a 4% interest rate. At the end, he'll have $1,000,000. I'm sorry, 1,000,000 Turkish lira. Okay? All right. Next problem. So we've got Trenchy has been left an annuity of 5,000. What is that? Euro? I'm not sure. I'm terrible with symbols, money symbols. So an annuity is for 5 years at 8% per annum, so at yearly, to be paid out monthly. Okay, so we want to find out those monthly payments. So she's been given 5,000. She's supposed to get that over the next 5 years. Okay, with an 8%. I don't know what you want to call it. Think of it like interest. Okay, so let's do N. N is 60. Why is it 60? 5 years, paid out monthly. So now it's the number of times is going to be 60. Okay, each month paid by the number of years. The next one is our interest rate. So our interest is going to be 8% over the next 12 months. So notice it's 8 over 12. Okay, notice that change there. So the annuity per annum to be paid out monthly, we divide the interest. Then our present value is 5,000, okay, because that's what it started with. It started with that already in there. I didn't lose any of that money. Okay, our FV, our future value, is 0 because we're not supposed to have anything in there at the end, right? And our PPY and CPY. Okay, so then we're going to move it over the payment, our cursor over that, and hit alpha enter, and we should get 101.38. Okay, so that's how much they're going to get each month for the next 5 years. Okay, with an 8% interest, yearly interest. Okay. All right, let's do another one. Okay, so similar example, but this, again, very similar, but now it's called amortization, and that's when it's decreasing in value. All right, so Tejas got a loan for $35,000 for a car, and the loan is for 10 years at 1% interest per month. Okay, so N is going to be, let's see if you're getting this right. Oh, my mouse isn't working, sorry. 120. Why is that? It is 10 years, each month you're paying. So 120 payments. Your I, your interest, is 1%. Okay, per month. It's 1% per month. It doesn't say per annum per month. Okay. PV, present value, is 35,000. Okay, she didn't lose any money. I'm sorry, they didn't lose any money, but that was what they were given. The future value is 0. That's how much they've got to pay off. The PPY and the CPY, leave those as 1. Okay, we're not talking compound. All right, when you solve for the payment, you should get 502.15. Right, so that's how much they have to pay each month for the next 10 years to pay off a $35,000 loan at a 1% interest per month. Okay? Hopefully that makes sense. If not, you know where to find me.